Alright, today we're going to talk about finding a real number solution for an equation, so actually solving these all the way. In section 2.4, we've just been talking about different methods of factoring. So example 1 was factoring on a monomial. Example 2, we introduced the sum of cubes and the difference of cubes. In example 3, we did grouping, and then 4, we did grouping and some other patterns. This really should be example 5. But for example 5, we're just going to take this one step further. We're going to factor like we've been seeing, but it's set equal to 0 now, so we're going to have specific solutions. Remember, when we factor these polynomials, what we're finding is the x-intercepts. So if we look at part A here, we can start by dividing out a 4x, which would leave me with x to the 4th minus 10x squared plus 9 equals 0. And then yesterday we said there was a pattern. If this is a power and then this is half of that power, you can actually use this special little trick where you just say, okay, this is going to be 4x, and then it's going to be times x squared plus or minus a factor, x squared plus or minus a factor. And that factor comes from what multiplies to positive 9 but adds to negative 10. That'd be negative 1 and negative 9. So negative 1 and negative 9. And then we have to double check, since there's a square inside the parenthesis, we need to figure out if we can do more factoring. In fact, we can. These are both differences of squares. Let's go ahead and solve them at the same time. So a is x here, and b is 1. And then this a separately is also x, and your b here is 3. So this would factor as 4x times x plus 1, x minus 1, x plus 3, x minus 3. So lots of factors. So what chapter 1 told us is, since these are all products, you can take each part separately and set it equal to 0. So you have 4x equals 0. You have x plus 1 equals 0. You have x minus 1 equals 0. You have x plus 3 equals 0. And x minus 1 equals 0. And really, this step you most of the time don't have to write, especially if there's just a 1 here. It just flips the sign. So here you'll have x equals 0. Just divide both sides by 4. X equals negative 1. X equals positive 1. X equals negative 3. And x, oops, I put plus or minus 1. Change that real quick, sorry. It should be a minus 3. Oh, I did it in both places. Minus 3. X equals positive 3. There we go. Make that fix if you were going along with this. So these are all of our solutions. How I would like you to enter these on GoFormative is put them in number order from smallest to largest. So you just write negative 3, negative 1, 0, 1, 3. So that's just how you're going to enter them on GoFormative, but those are your solutions. So what do those solutions actually mean? I graphed this graph for you. So this was our function from part A. This was what we factored it to. And then we found the solutions were x equals 0, x equals negative 3, x equals positive 3, x equals negative 1, and x equals positive 1. So if you look on the graph here, we have our solution. Our first solution should be at negative 3. There it is. Our second one is at negative 1. Then we have a solution at 0. You have a solution at positive 1 and a solution at positive 3. This is actually how I write the examples. When I want you guys to look at a graph and like evaluate the degree, I just write it this way, and then I expand it out. But this is how you can see distinctly these x-intercepts. So let's look at another example. Part B here, we're going to do the same thing, but before you get started, you need to make sure that this is equal to 0. So subtract 14x to the third from both sides. And then more specifically, I want you to put this in standard form. So it should go in front of the 24x, but behind the 2x to the 5th. So we have 2x to the 5th minus 14x to the third plus 24x equals 0. Now we can pull out a 2x. So you're left with x to the 4th minus 7x squared plus 12. equals 0. So we're going to use this trick again, x squared and an x squared. What multiplies to 12 but adds to negative 7 would be negative 3, and negative 4 will get us there. So minus 3 minus 4. Now we need to check this parenthesis is done because 3 isn't a perfect square, but this one is a difference of squares, where a is x and b is 2. So this will factor as 2x times x squared minus 3, and then this would be x plus 2, x minus 2, all equal to 0. So when I set these equal to 0, I would have 2x equals 0, x squared minus 3 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So this one would be x equals 0. This one's a little trickier. We'd add 3 to both sides, so you'd have x squared equals 3. So x equals the square root of 3. Here we'd have x equals negative 2, and here we'd have x equals positive 2. So in general, when I ask you for these, I'm asking for the real number solutions. So when you put these in, this is a real number. Real numbers just don't have an I in them, but it is a decimal. So you would enter this as negative 2, comma, 0, comma, square root of 3, comma, 2. If we look at the graph of this function, this was our part B, we said that we got an x equals 0, x equals negative 2, x equals 2, and then we had x equals the square root of 3. So the square root of 3 is some decimal. We can see here, though, that negative 2 is right here, and then we have a solution at 0, and then we have a solution at 2, and you know what? I forgot something. Really, this should be a plus or minus, because our decimal, this is our negative square root of 3, and this would be our positive square root of 3. So really, you do need that plus or minus. Let's add that up here. For part D, again, we need to put this in standard form first. So let's subtract 12x to the third from both sides and add 16x. So we'd have 2x to the fifth minus 12x to the third plus 16x equals 0. I can pull out a 2x. So I'm left with x to the fourth minus 6x squared plus 8 equals 0. So now I need to decide what multiplies to 8 but adds to negative 6. This would be negative 2 and negative 4. So when I factor this, I'll have 2x, and then I'll have x squared minus 2, and x squared minus 4. 2 is not a perfect square, so this is done. But this one is a difference of squares, where a is x and b is 2. So this will factor as 2x times x squared minus 2 times x plus 2 and x minus 2, all equal to 0. Alright, so hopefully you can see that we're going to have an x equal to 0, comes from this one. We'll have x equal to negative 2, and we'll have an x equal to positive 2. Really the only mathy stuff we have to do is this guy right here. So this one would be x squared minus 2 equals 0, so you'd have x squared equals 2, so you'd have x equals plus or minus the square root of 2. So when you put this in order, your answer would be negative 2, comma, 0, comma, plus or minus the square root of 2, comma, 2. You could also write this as -2, comma, negative square root of 2, comma, 0, comma, square root of 2, comma, 2. Either way would work. I'll put in both ways for go formative. So if we look at part D, did I skip C? Oh my gosh, I did. We'll go back to C in a second. If you look at part D here, we said that x equals 0, x equals 2, x equals -2, and then we had x equal to plus or minus the square root of 2. So if we look for all of those solutions, I see one at -2, I see one at 0, I see one at 2. This is my square root of -2, and this is my positive square root of 2. So you can see all those solutions on the graph. All right, sorry, let's go back to C. Don't know how I missed it. Putting this in standard form, we just have to add 6x to the 4th, and we should add it to the front. So we have 6x to the 4th minus 27x to the 3rd plus 15x squared, all equal to 0. Start by dividing out a 3x squared. So that'll leave us with a 2x to the 2nd minus 9x plus 5 equal to 0. Now I need to see if this will factor. So I'm going to have to do factor by grouping, where this is 2 times 5 is 10. So I want to list the factors of positive 10 that add to -9. So -1, -10, -2, -5. So this one does not factor further. So we have 3x squared times 2x squared minus 9x plus 5 equals 0. We could check and see if this discriminant is negative. So if you plug this through, remember the discriminant is b squared minus 4ac, and if it's negative, that means it's complex, and I only asked you about the real solutions, so not the imaginary ones. So this would be -9 squared minus 4 times 2 times 5. So we would have 81 minus 40. So this is a real solution, but we'd have to put it through the quadratic formula. I don't think I put any like this on your homework, so I'm just going to call this good enough. And we'll just find this one solution here, this 3x squared for now. So we have 3x squared equals to 0, so x equals 0. I'll revisit this one with you when it's not on a video, just because we'll have to go through the quadratic formula again. So for this one, it's good enough to just look at x equals 0. So if you look at part C here, you can see our x equals 0 solution is here. And then we have a bunch of other gross solutions. So this solution right here, that solution right there, and that solution right there are all pretty ugly. Oops, actually that's not a solution I care about. It's a vertex. It's really only these two solutions. So we'll come back to those at another time. So last one, let's just look at E together. Let's subtract 18x to the 3rd. So I have 3x to the 5th minus 18x to the 3rd plus 15x, all equal to 0. Can pull out a 3x, so that would leave me with x to the 4th minus 6x squared plus 5 equal to 0. I want to find the factors of positive 5 that add to -6. -1 and -5 would get me there. So I have 3x times x squared minus 1, x squared minus 5 equal to 0. This is not a perfect square, so it's done. But this one is a difference of squares, where a is x and b is 1. So my factors would be 3x times x plus 1, x minus 1, and then x squared minus 5. So when I factor this, set this equal to 0, I'll have x equals 0, x equals -1, x equals +1, and then this one I would add 5. I guess I'll just write it out. we'd have x squared minus 5 equals 0. You'd add 5, so x squared equals 5. Take the square root, x equals plus or minus the square root of 5. So my final answer would be negative 1, comma, 0, comma, 1, comma, square root of 5, plus or minus. Or you could write it negative square root of 5, comma, negative 1, comma, 0, comma, 1, comma, square root of 5. Either way would work. So this is what you're going to do for this last homework assignment. If you have any questions about it, let me know. And then, like I said, it shouldn't have any where you come across something like this. It should look more like either example 4A, where it has all nice looking solutions, or you might have some square roots in there.